Okay, we're working problem number 13, and it says to find the rate of change of the distance between the origin and a point moving on the graph of y equals x squared plus 1 if dx dt is 2 centimeters per second. So we have y equals x squared plus 1. We have that dx dt is 2 centimeters per second. And we're looking the distance between a point and a point on the graph that's moving. So if we think about what this graph looks like, y equals x squared plus 1 is going to look like this. And we want the distance between this point and on the graph. So I need some formula that's going to help me out here. It just says find the rate of change if dx dt is 2 centimeters per second. Andrew?
Pythagorean formula when solving for c, and then you can fill in the x squared plus 1 for y. Like, say, okay, your thing is equal to square root of x squared plus y squared, and then just fill out the x squared plus 1 for the y.
Would that be the distance formula?
Distance formula. I think you're right. I think what you're saying, what you're thinking is correct. Just some random point here on here is going to be some point x, y. Is that correct?
Yes.
All right. And to find the distance between these 2 points, what do I have to use? I use the distance formula. What is the distance formula?
Square root of x squared plus y squared.
Distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's the distance formula. That's one of those formulas, William, that we need to know. Okay, so one of our points is what?
0, 0.
0, 0. So that's going to make it a little bit easier. And you're right, it's going to end up being x squared plus y squared, but that's because x1 and y1 are 0. So I'm just going to go ahead and do it this way, just so everybody can see where it comes from. So we get the square root of x squared plus y squared. Okay, so that's what you were doing. Now, let's think about this. We have a value for dx dt. Do we have anything for dy dt? Any information about dy dt?
Can you find dy dt with y is equal to x squared plus 1?
No, but do we know what it is at any point? No initial information about dy dt. And I'm looking for the rate of change of the distance. No information about dy dt. So what could I do so that when I take a derivative, I don't have dy dt?
Substitute in y.
Substitute in y. And exactly what is that?
X squared plus 1 squared.
Okay. So for this y value, I'm going to substitute in x squared plus x squared plus 1 squared. Everybody okay with that? All right, so move up just a tad. I'm going to multiply out what's underneath the radical. So we have x squared. What is this when I multiply it out? X to the fourth.
It's 2x squared.
It's 2x squared plus
Good. I wanted to be sure and hear somebody do that because you'd be surprised at how many people would just say x to the fourth plus 1. Okay, so this becomes the square root of, the distance is the square root of 4x to the fourth plus 3x squared plus 1. So far, so good? Did I do that right?
Yes.
Okay, so we've got what's underneath the radical.
Find the
And
derivative of it.
now I need to find the derivative. Now, one thing that we can say, because whenever this is the smallest, this is going to give me the smallest distance, isn't it? When this is, did I ask for smallest distance? I may be getting ahead of myself here.
It'd be 0, if you put in a 0 for x, it'd be 1.
Yeah, we'll go, yeah, never mind. I'm thinking next lesson. Excuse me. Okay, so you're right. We're going to take the derivative of both sides. Let me move this up just a little bit.
We're doing that because that gives us a slope at every point.
Yes. That would give us the rate of change anywhere. So when we do, we know that this is the same as saying d is equal to x to the fourth plus 3x squared plus 1 to the 1/2. So when I take the derivative with respect, the derivative of the distance with respect to time, we're going to get 1/2 x to the fourth plus 3x squared plus 1 to the negative 1/2 times 4x cubed plus 6x dx dt. And I'm running out of room here, but you know that that's dx dt.
Why do you do the whole dx/dt?
Okay, I could say 4x cubed dx dt plus 6x dx dt, and then I just went ahead and factored it out.
Because the t's on the bottom, so you can't do the derivative of 4x squared.
Correct. Correct, because we're doing it with respect to time. All right, so if we simplify this,
Oh, okay, so 4x cubed is 6x dx dt on the outside of that?
Yes. Sí, señor. Let's go.
I just kind of did 2 in 1. I factored it out as I took the derivative.
Is dt always going to be on the bottom?
And these related rates, I don't remember any that weren't with respect to time. Okay, so now we can simplify, and we have this moves to the bottom. And if we take 1/2 of,
Can you finish on that radical? It makes it look like it's plus 1, I think.
okay, if we take 1/2 of this, I'm going to get 2x cubed plus 3x dx dt. But don't we have some information about dx dt?
Whoa, isn't dx
dxdt is to the power.
It's dx dt is on the outside though.
I was running out, okay,
They're supposed to be columns, right? Yeah,
and what is dx dt?
2.
2. So if we substitute a 2 right here, I'm going to have 4x cubed plus 6x over the square root of x to the fourth plus 3x squared plus 1. And we did that using the distance formula.
Cool. Is that the answer?
That is your answer.
That's d.
That is the derivative of the distance with respect to time. And it asks you to find the rate of change of the distance. So that means you're going to use some kind of distance formula there.
All right, number 6.
Okay, Matt, you've got a question.
What?
You have a question.
I do?
You look like you have a question.
Oh, yeah. What happened to the dx dt?
That is 2. Okay, we're doing 16. A is the area of a circle of radius r that's changing with respect to time. So you told me the area of a circle is what? Pi r squared. And it's changing with respect to time, so what's the derivative?
dA over dt is what we're solving for.
Pi r dA over dr over dt.
derivative here?
Pi r dr over dt. 2 pi r dr over dt.
Okay. That looks like a familiar formula,
it's
doesn't
saying
it?
If dr dt is constant, then is
Okay, if dr dt is constant, is the rate of change of the area constant?
Yes. No. Yes.
No.
Yes, no, maybe so. Why not?
Wait, constant meaning, like,
It's-
if it's saying it's constant, is it always, like, always 2?
Yes.
So then yes.
No, because radius is also multiplied into that
All right. Say that again?
again. Because the radius is also multiplied into the equation again. It's not just 2 pi dr over dt. It's 2 pi r dr over dt.
Correct. All right, so it is, the rate of change of the area is not constant.
Because the
Because
radius changes.
every time the radius might change, the rate of change of the area is going to change. So if the radius was constant and the change in the radius was constant, then the change in area would be constant. But because we still can have a variableness here with our radius, no, it is not constant. And then what was the last one?
22.
Any questions on 22, or was that one pretty easy?
Pretty easy.
So here we were at what rate is the height of the pile changing when the pile is 15 feet high? Was that the first? Oh, that's 23. Okay. When the radius is 6 inches, what's the rate of change of the volume?
I didn't feel like working out the, we worked out the cone derivative, right, earlier. We did it in our notes. The derivative of the cone, of the volume of the cone.
Well, it depends on whether you had all the information you needed. Did you have to use the
Well, I just
product
used the
rule,
equation,
or
right? I
did
just
you use
used
a substitution?
the product rule.
Did you have enough information to use a product rule?
Yeah. It tells you what the volume of the thing is.
Okay, we're looking at 22. The formula for the volume they give you. Find the rate of change if dr dt is 2 inches per minute and h is 3r. So if we know that the volume is what they give to us as 1/3 pi r squared. When I take the derivative of this, if I use the product rule, what kind of rates of change am I going to get?
Not constant.
Well, I'm going to have dv dt, dr dt, and dh dt.
You have to find all of them.
What
But
are we
they give
trying
us
to
some of them.
find in this question?
Rate of change of the volume.
Rate of change of the volume. Okay, so we want dv dt. What are we given?
We were given dr over dt is 2 inches and the height is 3r.
2 inches per second, I guess, or?
Yes. Nah, per minute.
And height is 3r?
Yes.
What is conspicuously missing? DHDT. Do I have any information about DHDT? If I use the product rule, is DHDT going to be in my derivative? If I use the product rule, is DHD, yes, it would be. So what do I need to do so that I don't have DHDT in my derivative, Adam? Okay. Substitute the H for 3R. Good. And so now we get 1/3 pi r squared times 3r, which gives us what?
Then you have to find the derivative.
Well, what is that when I multiply it out?
3r squared.
Pi r cubed. Now, when we take the derivative, William, what do we get?
Three R squared.
3r squared?
3 pi R squared.
3 pi r squared.
Oh, I forgot it's a channel.
dr dt, and that equals to what?
2.
No, but
Volume.
volume?
DV.
dv dt. Okay, and so we know that dr dt is 2, and it asks us to find the volume when r is 6 inches, and then when r is 24 inches. Can you do that pretty easily now?
Yep.
You just substitute when r is 6.
Does it change to be 6 pi r squared since the dr dt is 2?
This becomes 36 times 3
I'm saying
times
before-
2.
Before you substitute in.
Does it do what?
Before you substitute in what r is,
Uh-huh.
and dr over dt is 2, is it just 6 pi r squared?
You could use that as long as you have shown this somewhere.
Okay.
Okay, so we know that we could say 6 pi r squared, since we know that dr dt is 2. So when r is 6, dv dt is 36 times 6. 6 times 6 is 36. I think that was 216 pi. Was that right? And this is inches. What kind of inches? Cubed, because we're talking volume per minute. And so you would do the same thing with the 24.
Just checking.
All right. We're going to work on these again today, because I think that these related rates are important enough that you need to get a good grasp of how they work.
36 times.
I have no idea why you would assign pairs.
Okay, your assignment is on page 149, 27, 28, 30, only A and B, 41, and then page 155, 107. Okay. We will have a quiz on Wednesday over related rates. I wrote it up here. And next Tuesday, plan a test on 2.5 through 3.1.
And Thursday, notebook.
And next Thursday's your notebook, yes.
What do we have on Friday?
We're going to talk about
The no quiz.
extrema on Friday,
Warmed up.
maximums and minimums on closed intervals.
No quiz.
Not on Friday.